Hey everybody, Mr. Murphy here. Welcome to another video lesson. This one is on the properties of secants and tangents and how to solve for unknown lengths using those two types of lines, specifically when they meet outside of the circle. So, I'm going to go over first what is a secant and what is a tangent, just to remind you, and then the same relationship can be applied for both. So, what is a secant and what is a tangent? A secant is any line or line segment that touches the circle twice. So for example, on number 1, those two lines are both secants. A tangent touches the circle exactly once. So that would be something like on number 2. This 12-unit line is going to be a tangent. Okay, so let's practice solving for these missing lengths using secants and tangents. Now, in each problem, the secant and the tangent are going to meet outside of the circle like this. Like on number 1, they meet right here. So regardless of whether you're dealing with secants or tangents, the relationship that we're going to use is the same. And it's going to look like this. For both of the lines that you see, we take the whole length times the outside length, set it equal to the whole length times the outside length for the other line. So on number 1, that's going to look like this. The whole length of this line times the outside length, which is the 6, equals the whole length of the green times the outside green part. So like this. The whole times outside. The whole would be 6 plus 8 times the outside would be 6. Then for the green line, the whole thing would be equal to x plus 7 times the outside, which is 7. Okay. Now, of course, I do things like, if I see 6 plus 8, go ahead and combine that to a 14. On the other side, I can't combine yet. But what I can do, since I'm multiplying that 7 into the parentheses, I can distribute. So 7 times x is 7x. 7 times 7 gives me plus 49, kind of like that. Alright, so 14 times 6, 6 times 10 is 60, 6 times 4 is 24, that works out to 84. And then on the right side I still have the 7x plus 49. Now, this should look pretty familiar. From here we just kind of draw our line, and we want to get x by itself. So take away this 49, minus 49. That leaves me with 35 equals 7x. If I divide both sides by 7, divide by 7, I get x equals 5. So for number 1, answer should be x equals 5. Okay. Cool. So just the key points here. When you're setting up this whole times outside part, remember for the whole length, you have to add the inside length plus the outside length. So 6 plus 8 for that line in this case. And then the outside part is usually just one length, so you just take that number. Now, if your whole length includes an x, you're going to have to put it in parentheses, like this x plus 7 we did. Okay? Cool. Alright, now let's take a look at number 2. Number 2 is similar, but if you notice, we have a tangent this time. So I want to show you something cool that happens when you have a tangent. So, first I'm going to set up the secant, this line that crosses twice, as orange, and the tangent as green. Now the tangent touches the circle at only that point. Okay. So again, if I want to solve for x, I know the lengths of these two lines will follow this rule. Whole times outside for one equals whole times outside of the other. So I'm going to do the orange line. The whole thing would be x plus 9 times 9 equals, and then for the tangent, what's cool about the tangent is that the whole line, which is 12, is equal to the outside portion, because the whole tangent is outside of the circle, except for this point. But that point has no length, so the whole length is on the outside. So for the tangent line, just do this, 12 times 12. Whole is equal to outside. Okay, now of course that gives you 144. On the other side we distribute. So 9 times x and 9 times 9, that gives me 9x plus 81 equals 144. Now, take away the 81. That leaves you with 9x equals, what is that, 63. Divide by 9. And you should get x equals 7. Okay. Alright, so very much the same steps we just did over here, but if you notice for that tangent, the tangent length, the outside length is equal to the whole thing. So you just use the same number twice there. So 12 times 12. If that number had been 6, do 6 times 6. Same idea. Okay? Alright, now I'm going to do a couple more difficult problems that go a little bit further, but essentially they still use the same relationship of whole times outside equals whole times outside. Let's try it out. For number 3, we're going to use that relationship to help us solve for the length of this line segment QR, which right now is equal to x minus 1. That means we're going to have to solve for x and plug it in. So there's that secant line. We can do whole times outside for that, equals whole times outside for the green one. So let's do that now. When I'm doing the whole thing for the orange line, I have to take x minus 1 plus the 10 and then multiply it by the outside, which is 10. Same thing for the green line. The whole thing would be equal to x plus 2 plus the 9, that's on the outside. And then the outside is just going to be that 9. Okay. So kind of slightly longer because we have more pieces, but the relationship is still the same one. Okay. So now just simplify what you can first. For instance, in these sets of parentheses, x, I don't have anything to add it to, but minus 1 plus 10, that's a negative 1 basically, becomes plus 9. And then keep the 10 on the outside. And then over here, I can do x, because there's no other x's, 2 plus 9 gives me plus 11, and bring down that 9. Alright, so combine your like terms. Now, I can distribute like I did before, 10 times x, 10 times 9, that's going to be 10x plus 90. And then over here, 9 times x, 9 times 11, gives me 9x plus 99. Okay, cool. So now I have variables on both sides, but no problem. I can still just draw my line and start solving. I like to have my x's on the left, so I'm going to do this. Minus 9x, that cancels. 10 minus 9 is 1, so I can just write that as x plus 90 equals 99. Take away 90 from both sides, and you get x equals 9. Okay, now, since we wanted to find QR, don't forget to do this last step, where we take the x that we got and we plug it into x minus 1. So that'll look something like this. QR equals 9 minus 1, which is just 8. Cool. So yeah, as with any geometry problem, if you're doing algebra to solve for a number, make sure you know whether or not that number is supposed to be your answer, like the first two, or whether you have to plug it in, like number 3, to find a missing angle or segment or whatever. Okay? Alright, let's do one more. Same idea. We have two secants that meet, so we're going to do whole times outside again. So that'll look like this. Let's do the orange line and the green line. Okay. So for number 4 on the orange line, the whole line would be equal to 4x plus 6x. That's going to be 10x. And then the outside portion, the outside length, is 4x. So I'm going to do 10x times 4x on the left. On the right, I'm going to do the same thing with this line. The whole length would be equal to 5 plus 3, which is 8. The outside would be equal to 5. Okay, now what's different about this example? Well, if you look on the left, I have 10x times 4x. In the other examples, we have not multiplied variables yet. So just remember what happens when you do. 10 times 4 becomes 40, but also I have to do x times x, which becomes x to the second, or x squared. Alright, on the other side, 8 times 5, that's simple. That's just 40. Okay. Cool. So now, when we're solving something like 40x squared equals 40, you always want to take the number in front and divide by it to cancel first. So 40x squared divided by 40, that cancels the 40s. And then over here, 40 divided by 40, that's the same number, so that just equals 1. And then I'm left with x squared as a result. Okay, now, of course, you should remember how to cancel out x squared. We have to take the square root. Square root of x squared gives us x, which is what we're solving for. And then square root of 1 is asking what number times itself equals 1, which the answer to that is also just 1. Cool. Alright, so you may run into those situations where you're multiplying the same variable twice, in which case make sure you don't forget to do x squared or y squared or whatever the case may be. Okay? Alright, that's going to wrap us up for this video. If you need to go back to any of those examples, remember you can always pause, rewind. I'm going to include the problems in the comments of the video for you so you can work them out yourselves while you're watching. And hope this helps. Have a good day, guys. Look out for an assignment going along with this, either today or tomorrow. And have a good week.